Welcome to our presentation. We are the team of Jungle Meat. Our project is a movie forum. Let's get started with our quick demo video first. Thanks for watching the demo video. Now I will give you a more detailed explanation of our project. Jungle Meet is a multifunctional interactive forum. It is a place for people to watch the movie discussion, where people come together to share their opinion. We are also a community pushing for positive change for people. We implement some technologies that may be different compared to the other groups. Technologies such as Next.js Frame, Socket.io, i18 Next, and Infinite Scroll. Here is our overview for today's presentation. We will talk about the page overview of our website, followed by the key functions, and then the tech stack that we use on our website. And finally is the DevOps team's presentation. Before we proceed further, let's go through our website first. This is the home page. As you can see from the layout, all movie showcase related sections are placed at the top half of the page, including now playing movies, upcoming movies, popular movies, top 10 movies, and trailer sections. The discussion related sections are divided into two parts. Top 10 posts and discussion display parts are display posts sorted by the view and date. We also added an advertisement space on both sides of the page. You can see that it is in holiday promotion. If you click a More button in the upcoming tab, it brings you to the All Movie page. At the All Movie page, it shows all movie we have. User can filter movies by different conditions, such as year, movie type, and sort by function. When you click on specific movie card, it will navigate user to movie detail page. In the movie detail page, user will find movie relevant information like title, cast, duration, trailer, and etc. In addition, the user review is at the bottom. When you click review button, it takes you to review page showing related review and reply in the nested format. Let's talk about discussion section. The discussion page can be navigated through clicking the More button of the post item of the home page or through the top hamburger icon. By default, the discussion post will be sorted by most recent, and it can be sorted by view number. When you click on individual post, it takes user to the discussion detail page. Here, user can see the post content and user nested comments. For user profile page, clicking username or profile item at the top hamburger icon, it will take user to profile page where sign-in user can modify their own avatar image, background image, password, or look through their own posts as well as the real-time messages. To sum up, here is the page overview for those 7 pages we just mentioned, which make up the main structure of our movie forum. We have designed the forum to be responsive for desktop and iPad. Contents are customized based on the screen size to show appropriate data accordingly. We have used the Chakra UI library and style components for components development. Now we move on to the overview of all key functions. The key functions can be categorized to both of the user side and the admin side. The user side function includes browsing information across the various pages, register and login, customer profile, and interactive actions. And for the admin side, it contains the management of the post. You can also use the filter function to see all the movie list or use the sort by function. For the discussion list page, you can change sort by setting to either most recent or most view order. You can also use search bar in the nav bar to search for the desired movie or post easily by typing a few characters. As a user, you can also view other users' profile by clicking any username. It brings you to the user perspective profile page showing the post and follow related information. Apart from browsing information, the key function of user also includes creating an account and logging to their corresponding account. Reset passwords are also included in the user side. When you wish to reset the password, you will receive an email from us containing reset link. You can change the password whenever you want. After becoming a user, you can change personal avatar and background image to something else you like. When you upload image, you can crop it into your satisfied size before uploading. Let's turn to the interactive actions. It covers creating posts, leaving comments, changing languages, and real-time notification. First, it is creating a post for the sign-in user. Next, it is leaving comment. The review function is only open to sign-in user. If you click review button, it will either pop up a login model for guest or editor for sign-in user. At this place, you can write down your comments on corresponding movie, and all of our comments will be shown in a nested format. Next, any user can change languages through the multilingual function provided by I18 Next. And the last is the real-time notification by Socket.io, and that's all for the function available in the forum. Now we move on to the tech stack we have chosen to use on our project. I will start off with the front-end technology such as Next.js, TypeScript, Chakra UI, Style Component, Socket.io, Redux Toolkit, I18 Next, and Infinite Scroll. What worth to say is the Socket.io is for real-time notification. It will send message when user need to be notified because of user-related action. The I18 Next is used for multilingual purposes. It will change router when switching languages. Last but not least, we implement Infinite Scroll to achieve infinite scrolling of the movie list. When scrolling reaches the end of the page, it will reload new movies to make the scrolling continue. For the backend, we have Node.js, Express for Frame, MongoDB as a database, Node Mailer to achieve send email with reset password link, Swagger for the simplified API development, and JWT for the user login security. Now let's pass it to the DevOps team.
Hi, thanks, Eric. Hi, everyone. I'm Cassie, and I'm going to introduce our front-end architecture. We used Vercel to host our static website pages because of the Next.js framework. Our domain name is managed in Load 53 by configuring needed records and state names. And the user can access the web page from browser, and the traffic is routed through CDN, which is AWS CloudFront. CloudFront can help to accelerate content delivery while storing cache of our static website content. As a result, low latency can be achieved. In order to keep our traffic private and secure, we use AWS Certificate Manager to issue SSL certificates to be used in CloudFront. Thanks. Next, we have Aaron to introduce back-end part. Welcome, Aaron.
Hello, everyone. This is Aaron. I'll continue to introduce our three-tier architecture of our projects. As for our application tier, we used Amazon Kubernetes to deploy our applications in EKS cluster. EKS architecture is designed to eliminate any single points of failure that may compromise the availability and the durability of the Kubernetes control plane, which is managed by AWS. And we deploy worker nodes in the node groups in private subnets to prevent direct access through the internet to ensure the security. Then we created the net gateway in the public subnets to allow the backend to pull the image from ECR and ensure the backend services has a secured communication with the internet. When the customers use domain name to send HTTP requests in the web browser, the routes will be directed to the ingress controller, which can accept the traffic from outside the Kubernetes platform and load balance it to the pods running inside the cluster across 3 different availability zones. Net Gateway allows to send responses to our customers In addition, the Kubernetes horizontal auto-scaling will ensure the backend applications to handle the increased traffic. And finally, we used Amazon CloudWatch with Fluentbit, Elasticsearch, and Kibana to manage the logs of the applications and the cluster. Fluentbit will collect the logs and send it to the Elasticsearch. And we use the Prometheus and Grafana for monitoring. All of our cloud infrastructures were deployed through Terraform and Ansible YAML scripts to achieve the efficiency and consistency. Next slide, please. And furthermore, we have another backup plan in case there's a sudden disaster. We deploy our backend applications into Fargate containers into 2 different availability zones and load balancer to distribute HTTP requests to these Fargate containers. Auto-scaling policy will also be applied to our backend. If the traffic increases and goes beyond the preset percentage of the CPU utilization, it will spin up another new containers automatically to satisfy the increased load. Now I will pass the next part, CI/CD, to Cass. Thank you.
Thanks, Aaron. I'm Cass, and I'll introduce the CI/CD procedure. For the front end, we configure multi-branch pipeline with Jenkins to test the code and use Vercel to build, deploy, and host the website. Whenever a branch is pushed or merged into the main branch, the Jenkins pipeline will run on a cube to test the code. Once the code passes the test and merge into the main branch, Vercel will start to build and deploy the website. Next page, please. And the backend is also configured with Jenkins multi-branch pipeline, and the process of the trigger setup and code tests are the same as front end. If there are some major problems with the code, the pipeline will be automatically terminated and send a notification to the team. After successing the code test, we use Docker to build the image and pass in the credential parameters to connect the database. All the credentials are stored in the Jenkins credentials and can be retrieved whenever needed. When finished building the image, the pipeline goes to use Trivy to scan the image's vulnerabilities and push it to the AWS ECR for image storage. After that, the deployment is on the Amazon EKS using the image we push to ECR, and we configure a YAML file to apply our app in separate nodes with auto-scaling enabled to ensure the high availability. And we'll be notified whether the pipeline is running successfully or not. Meanwhile, we also put our app on ECS Fargate for backup, deploying the app by automatically updating task definition and services. In addition to all those processes, the servers we use in the process, such as Jenkins and SonarQube servers, are both configured with Terraform and Ansible so that we can spin up servers very easily. Now I'll move on to Boris.
Thanks, Cass. So we also have our infrastructure as code, which is Terraform in the CI/CD pipeline. It updates previously mentioned infrastructures whenever pull request is merged or pushed. We use Terraform to launch not only the basic structures, for example, VPC, subnets, internet or net gateway, even EKS cluster, nodes group, etc., but also to set up event bridge to trigger 2 Lambda functions linked with the step function, which I'll go through in a bit more detail later in the slides. We then configured EKS cluster with Ansible to add features like Nginx ingress controller, network balancer, Prometheus for monitoring, EFK for logging, etc. So which brings us to the next topic, monitoring and logging. So in terms of monitoring, we deployed Prometheus in the EKS cluster with Helm to get and analyze data, and then visualize the data with Grafana as the picture shows. We set up metrics according to the 4 golden rules, latency, traffic, errors, and saturation. We also created alerting rules so that whenever a metric crosses this threshold, our team would be notified by Slack messages. These just small pictures shows you the detailed parts, nodes, and services info with the numbers in the different namespaces in the table. And we'll also monitor different aspects in this project. We'll also monitor status of CloudFront and network load balancer to see cross-app traffic so that we can plan proactively. For logging, we deployed Fluentbeat, which is a fast and lightweight log processor, to scrap logs or data from EKS cluster and then send it to Elasticsearch to analyze it, then Kibana to visualize it. When it comes to troubleshooting, as the picture shows below, you can just search in the filter section to get the detailed logs for the specific pod, service, or the deployment. Finally, and yet importantly, here's some highlights in this project from DevOps point of view. We introduced serverless computing to reduce cost. As mentioned earlier, we set up SonarQube to scan source code, but it takes up a lot of memories and spaces, so we must launch a fairly large instance for it. That instance, as such, is not necessarily set to be running 24/7. So we set up event rules to turn on and turn off the instance on a schedule and be notified of the status of that particular instance via Slack messages, which is also done through Lambda function. Secondly, we integrated Jenkins credentials, SonarQube and Trivy in our CI/CD pipeline to enhance security. In addition, we utilized Kubernetes with ECS as backup to ease app deployment and management with scalability, availability, and cost optimization. Besides this, we provisioned and configured all the infrastructures by using Terraform together with Ansible. That's the end of the presentation. Thanks.